Alright, here we go. 1.3, rates of change and slope. First slide, rate of change. It's a ratio. Ratio is a fancy word for a fraction, typically, okay? But it's a ratio that compares how much one quantity changes on average relative to the change in another quantity. Okay, so it's a ratio that compares how much one quantity changes on average relative to the change in another quantity. These don't necessarily, and the reason why they say the on average part in there, rate of changes usually deal with your word problems. Okay, they're usually the ones with your tables from a scientific experiment, your graphs that have to do with sales, that sort of thing. Okay. As you'll learn later on, there's this other one we're going to do today called slopes, and that's very much straightforward, 2 points, yada yada. Okay. The formula to find your rate of change is you do the change in your y's, whatever y values you're using, divided by the change in your x values. So they write it as change in y over change in x. Every once in a while, as you guys move up in life and move into different courses, they'll write it as delta y over delta x. Delta means change in. That's what the triangle symbol is there for non-Greek letter people. That's a Greek letter delta. It means change in. You see it sometimes in physics, occasionally in a math course. If you take stats, you'll probably see more Greek letters than you want to. Okay, these are all.
Is there a stats class?
Yep.
What'd you do?
Miss that. Okay. So that's what we're going to do today. We're going to do rate of change first, and then we're going to do slopes afterwards. All right. So it should be mostly review, maybe a little bit, not mostly review. All right. So the table shows the temperature of a solution from a heat after it has been removed from a heat source. Find the rate of change in temperature for the solution. Now, sometimes the book is fairly vague as far as what they want you to do. Sometimes they're very, very specific. Okay? This one's kind of a vague one. All right? Find the rate of change in temperature for the solution. So, basically, if you look at the table to the left, it's pretty safe to always assume x is first, y is second. Okay, so your x column will be first, your y column will be second. All right, I don't know anybody that puts y second and x, or x second and y first. Okay, so that's pretty safe to assume. Now, the only problem in the vagueness of this problem is what stretch do we find the rate of change for? It doesn't really explicitly say. Okay, so if that's the case, you go from end to end. Okay, you go from end to end. Now, you can use those two data points and set up a two-ordered pairs. So 0 as your x, too soon, 143.6 for your y, and then 12 for your x, and 118.4 for your y. Okay?
Why 12?
Because it's the x one that goes with the 118.
Oh, you went
from end to end. Yep. Typically, if the book's nice, it'll be the same from 0 to 2 minutes, 2 minutes to 5 minutes, 5 minutes to 8 minutes, to 8 to 12. But you see how your times get longer? You know, a 2-minute interval here to a 3-minute, to a 3-minute, to a 4-minute. Which that part worries me about the staying consistent part, which is why your rate of change in the definition has the on average part. You know, because you pull something off the heat right away, it's going to cool down faster than it would, 8 minutes later. You know, as it starts to get cooler, it's going to start getting cooler slower as it gets closer to room temperature, right? Make sense?
Yeah.
So that's why they throw the on average in there. That's why I want you guys to go from end to end. Okay. Now to do this, you find the change in, which means the difference between, right? So 143.6 minus 118.4, and you divide that change in your y's by the change in your x's. So 0 minus 12, making sure you stay consistent, right? If your 143.6 went first from here, your 0 has to go first down here. All right? So the numerator becomes what? Someone help me out. 12 point. Should be a little more than 12, shouldn't it?
25.2.
25.2.
Oh,
The numerator becomes, or denominator, sorry, becomes negative 12, which becomes, I believe, what, a negative 2.1? Is that right? Which means, on average, from minute to minute, the temperature of that solution, whatever it is dropping by 2.1 degrees each minute. See how you interpret that? Okay. Questions on that one?
that's how you do rate of change.
Pretty much. Like I said, that one's kind of a vague one. They really don't, and those are the harder ones because you got to remember to go end to end. Is everybody good here? Okay. Sometimes, and most of the ones you'll get will be like this, where the book pretty much tells you what to do. This isn't in your current book. This isn't from the old book. So I just didn't update the slide. My bad. Anywho, if you don't have the slides pulled up, it's probably kind of hard to see, so I'll go ahead and write out these numbers, what they are. This one here is 89.2. This over here is 77.8. This down here is 12.8. And this over here is 0.2.
So would the percent be X?
Right. Or sorry, no. Year would be the X. Percents would be the Y.
So U goes on top?
Yep, because percent, see how years are on your x-axis? That's how you know. X-axis, y-axis. Okay, so years are your x's, percents are your y's. Go ahead, find them both. Find CDs, find downloads. Find the average percent, or the rate of change of the percent of total music sales for both the CDs and the downloads from 2001 to 2008. Okay, so let's go CDs first, is what I think I did. Yeah. All right, here we go. CDs. 77.8 was the percentage of music sales for CDs in 2008. 89.2 was it in 2001, right? So those are your Y's. You divide that by the change in years from there. So 2001, or 2008, sorry, minus 2001. All right? So these are for CDs. 77.8 from here, minus 89.2, divided by the years they represent, the years they go with, 2008, 2001. Alrighty. Should get a negative 11.4 up top, 7 on bottom. Equals about a negative 1.63. Alright. For your downloads, now pay attention how I write this one, okay, because I did this on purpose. Your downloads, I did from 0.2 minus 12.8 divided by 2001 minus 2008. Now on your CDs I did 08 first, your downloads I did 01 first. Does it matter? No.
As long as you have the same.
Exactly. As long as you remain consistent with the order, it doesn't matter which one goes first. Okay? So I did 0.2 first on downloads, which means when I do my denominator, I need to put 0.2's year first. So 2001. Okay? Up here I did 77.8 first. So in the denominator, I need to put the year it's associated with first, which is 2008. Okay? That's the only way. If you crisscross them, then you screwed up. Sorry, messed up. All right. Figure that out. It's negative 12.6 divided by negative 7 equals 1.8 squeezed in there. Okay. Slope. Moving on to slope. All right, slope. Notice the definitions will be very similar. There's like two different phrases that are different, or two phrases that are different in slope's definition versus rate of change. So here we go. Ratio of the change in the y coordinates to the corresponding change in the x coordinates. Okay? They throw in the actual coordinate word to you now, because slope is specifically dealing with lines, linear straight lines. Which means if you put them to graph papers, you will have graphs that you can get points off of. Or they give you straight off ordered pairs. Slope is very specific to the lines. That's the major difference. Okay? I'm going to back up real quick. Alright, just to show you. See how these two graphs, they're not exactly linear, right? They don't form straight lines all the way throughout. That's when you talk about rate of change. Okay, when it's over a span of years, and it may change vary from year to year how much your sales increase or decrease or what have you. Okay? Slopes are straight lines the whole way through. Alright? Now, if you remember from yesteryears, there's a thing called a slope formula. The fancy words to it are the change in the y coordinates divided by a change in the x coordinates, which you all remember it as y2 minus y1 divided by x2 minus x1. All right, everybody good on the formula? Make sure you write that down. Obviously, that's very important, because that's how you're going to find all these slopes the rest of the day. Okay? Everybody good? All right, so for those that have never seen this before, which hopefully isn't a whole lot of people, but we're going to go through this one step by baby step. Find the slope of the line that passes through the points negative 4 and 3 and 2 comma 5. So my formula is y2 minus y1 over x2 minus x1. This is an x, this is a y, this is an x, this is a y, this is my first x, my first y, my second x, my second y. That's how you figure them out. And then you plug them in. Alright, so 5 minus 3 all over 2 minus a negative 4. Which means 5 minus 3 is 2. 2 minus a negative 4 is 6. And 2 6 becomes 1/3. Fractions for slopes. Always fractions for slopes. Okay? Now, if I go 3 minus 5 over negative 4 minus 2 to get it, what's my answer going to be?
Negative 2 over negative 6 is 1/3.
1/3. Good. See what I did? I switched the order of the points. Okay, but I switched all the orders. Went to this point first, then this point second, negative 4 to 2. Where you're going to be messed up is if you go 5 minus 3 over negative 4 minus 2. That's where you're messed up. Okay, see how? Because then you go y2 minus y1 over x1 minus x2. See how the partners are across from each other? That's what I call crisscrossing your points. Okay? If you crisscross your points, your slope's going to be wrong. And later on, whenever we actually use our slope as part of our problem, the rest of that problem is going to be wrong because your slope's wrong. Okay? So it's very important to make sure you stay consistent with the order that you use your points in. Alright? Questions on that?
What is it?
What's what?
C3?
Right there.
No. Wouldn't it be 5 minus 3 over a negative 1 minus 2? No.
This is down here.
Yeah.
That's wrong
Why?
because you used the wrong points. Like you crisscrossed them. See how you used y2 first and y1 second, and then you went to using x1 first. You can't crisscross them. If you use the 5 first on your top, you got to use the 2 first on your bottom. Okay. Everybody ready? Oh, too fast. Hold on. Back up. Sorry. Didn't mean to go that fast. I'm a fast rider. Oh, that's still kind of fast, ain't it? Let's try like that. There we go. Everybody good? 5 minus negative 3 over 3 minus 1 equals 8 over 2, which is known as 4. Yay. Alright, still kind of fast. Let's go with that slow. Okay? Now, watch what I do with the second one here. Okay, so I went 5 minus 3, or 5 minus negative 3, 3 minus 1. This one down here, moving super slow. There we go. 11 minus a negative 9. See that? So I switched the order of the points I used. I did this one first and then this one. As long as you do the same way down here, it doesn't matter. Okay? But you have to do, whichever one you do first on the top, you have to do first on the bottom. That's the key. Okay? You should get negative 5/8 there. Alright? Also notice how my numerator was positive and my denominator was negative. When I reduce this, I move my negative up top. I want you guys to start doing that. Okay? Get in that habit because I want us to be consistent with where our negative sign goes. And that's in the numerator. Okay? So if the denominator is negative when you do your subtractions, get in the habit of when you rewrite it, because chances are you'll have to reduce at least a little bit, move it to the numerator. That way we're all staying consistent, and that way we're all, whenever we go graphing, we're all doing the same thing. Okay, same moves. Okay? Everybody good? Alrighty, last problem for the day. Oh, never mind. Hold on, we're skipping this. I think you guys can handle that by yourselves. Same with that one. That's the one I'm thinking of. Alright, find the value of r so that the line that passes through each pair of points has the given slope. Your points are 10, r, 4, negative 3. Your slope is 4/3. We learned y2 minus y1 over x2 minus x1. That is the formula for the slope, and they tell us the slope is 4/3 equals 4/3. Alright. So, 4 minus 10 down here, clean this guy up, is negative 6 equals 4/3. Now, I'm sure at some point some wonderful math teacher taught you guys how to cross multiply, yes? Alright, whenever you're solving a ratio like this. So these guys multiply. So 3 times negative 3 minus r. And these guys go this way. Negative 6 times 4, like that. Okay? Distribute the 3, so you get negative 9 minus 3r equals negative 24. Add the 9 over, so you get negative 3r equals negative 15. Divide by the negative 3, r equals, I'm in the logo, ain't I? Hold on, check out what I can do. Whoop, done. R equals 5. Alright, homework, page 24, 1 through 8, 31, 32.